Row 1. Text, Notepad window, text editor, editing, blank. Remember, this is not teaching man teacher. It is useful for recalling when exam coming man student. Just close eyes and listen. Based on G scheme for Electronics Engineering Group. Subject, Mechatronics, 17,660. These are mostly important questions which is always repeat, form top. To end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter. Download link is below.
I'll explain the working principle of solenoid valve. List the applications of solenoid valve. ANS, working principle, 2 MKS. A solenoid is a simple electromagnetic device that converts electrical energy directly into linear mechanical motion, but it has a very short stroke, length of movement, which limits its applications. A solenoid valve is the combination of a basic solenoid and mechanical valve. So a solenoid valve has two parts, namely electrical solenoid, mechanical valve. Solenoid converts electrical energy to mechanical energy, and this energy is used to operate a mechanical valve, that is to open, close, or to adjust in a position. Or note, students can draw any other correct diagram. Applications of solenoid valve. Any two applications, 1 MKS. Any other applications to be given marks. 1. Used in machinery devices and equipment, such as refrigerators and automatic faucets. 2. Used in heating system. 3. Irrigation sprinkle system. 2. Explain working of belt. List types of belt. ANS, working. A belt is a loop of flexible material used to mechanically link two or more rotating shafts, most often parallel. Belts may be used as a source of motion, to transmit power efficiently, or to track relative movement. Belts are looped over pulleys and may have a twist between the pulleys, and the shafts need not be parallel. In a two-pulley system, the belt can either drive the pulleys normally in one direction, the same if on parallel shafts, or the belt may be crossed, so that the direction of the driven shaft is reversed, the opposite direction to the driver if on parallel shafts. As a source of motion, a conveyor belt is one application where the belt is adapted to continuously carry a load between 2 points. Types of belt. 1. V-belt. 2. Flat belt. Timing belt. 3. Ribbed belt. 4. Film belt. 5. Multi-grooved belt. 3. State the working principle of gears and give its applications. ANS. Gears are mechanical elements which transmit motion by means of successively engaging teeth. Gears are used to transmit motion from one shaft to another, or between a shaft and a slide. Rotary motion can be transferred from one shaft to another by a pair of plain cylinders, or disc 1 and 2 as shown in figure A below. Power transmitted between two shafts is small, because there is a possibility of slip. In order to avoid slipping, a number of projections, called teeth, as shown in figure B above. According to the relative positions of their axes, they are classified as spur gear, helical gear, and herringbone gear as shown in figure below. Applications of gears. Differential analyzers. Agricultural equipment. Industrial construction. Mining equipment. Automotive equipment. 4. What are linear actuators? State any 4 applications. ANS, definition 2 mark, any 4 application -1/2 mark each, diagram is optional. Linear actuators. A linear actuator is an actuator that creates motion in a straight line, in contrast to the circular motion of a conventional electric motor. Linear actuators are used in machine tools and industrial machinery, in computer peripherals such as disk drives and printers, in valves and dampers, and in many other places where linear motion is required. Hydraulic or pneumatic cylinders inherently produce linear motion. Many other mechanisms are used to generate linear motion from a rotating motor. Applications: machine tools, disk drives, printers, valves, dampers. D. What is DC motor? Give its working principle with neat diagram. ANS. Definition: DC motor is any electrical machines that convert direct current electrical power into mechanical power. Diagram. Working principle. It is based on the principle that when a current-carrying conductor is placed in a magnetic field, it experiences a mechanical force whose direction is given by Fleming's left-hand rule, and whose magnitude is given by force, F equals BIL Newton, where B is the magnetic field in Weber/m2. I is the current in amperes and L is the length of the coil in meter. The force, current and the magnetic field are all in different directions. If an electric current flows through two copper wires that are between the poles of a magnet, an upward force will move one wire up, and a downward force will move the other wire down. The loop can be made to spin by fixing a half circle of copper, which is known as commutator, to each end of the loop. Current is passed into and out of the loop by brushes that press onto the strips. The brushes do not go round so the wire does not get twisted. This arrangement also makes sure that the current always passes down on the right, and back on the left so that the rotation continues. This is how a simple DC electric motor works. 6. State working principle of cam. List its types. Give 4 application of cam. ANS, working principle of cam. A cam is mechanical rotating machine element, which is used for converting one motion into another. A cam is a curved or grooved surface, which mates with a follower and imparts motion to it. In general, the cam may be rotating or oscillating, whereas the follower may be rotating, reciprocating, or oscillating. Diagram, optional. Types of cam. Applications of cam, any 4, 1/2 m each automatic machines. IC engines. Machine tools. Printing control mechanisms. Spinning and weaving machineries. Textile machineries. Paper cutting machines. 7. Draw and explain gear type rotary actuator. ANS. Explanation: rotary actuators convert energy of pressurized fluid into rotary motion. Rotary actuators are similar to electric motors, but are run on hydraulic or pneumatic power. It consists of 2 intermeshing gears inside a housing with 1 gear attached to the drive shaft. The fluid enters from inlet, causes the rotation of the meshing gears. The rotating gear carries the fluid from the tank to the outlet pipe. The suction side is towards the portion whereas the gear teeth come out of the mesh. When the gears rotate, volume of the chamber expands, leading to pressure drop below atmospheric value. Therefore the vacuum is created and the fluid is pushed drop below atmospheric value. Therefore the vacuum is created and the fluid is pushed into the void due to atmospheric pressure. The fluid is tapped between housing and rotating teeth of the gears. The discharge side of pump is towards the portion where the gear teeth run into the mesh and the volume decreases between meshing teeth. The fluid exists from the exhaust port. 8. State the characteristics of quick opening control valve. ANS. Quick opening provides large changes in flow for very small changes in lift. It usually has too high a valve gain for use in modulating control. so it is limited to on-off service, such as sequential operation in either batch or in semi-continuous process. 9. Enlist the various mechanical actuating system, and explain any one in brief. ANS 1. Force amplification e.g. levers 2. Change of speed e.g. gears 3. Transfer of rotation about one axis to rotation about another axis e.g. belt 4. Particular types of motion e.g. that given by a quick return mechanism 5. The 4-bar chain, and the slider, crank chain 6. CAM 7. Ratchet and pawl. Explanation: gear, rotary motion can be transferred from one shaft to another by a pair of rolling cylinders. The transfer of the motion between the two cylinders depends on the frictional forces between the two surfaces in contact. Slip can be prevented by the addition of meshing teeth to the two cylinders. Also, gears can be used to transfer rotating motion for shafts which have axes inclined to one another, i.e. the two shafts intersect. Bevel gears. Belt chain is essentially a pair of rolling cylinders with the motion of one cylinder being transferred to the other by a belt. The transmitted torque is due to differences in tension that occur in the belt during operation. This difference results in a tight side and slack side for the belt. Ratchet and pawl. It consists of a wheel, called a ratchet, with saw-shaped teeth which engage with an arm called pawl. The arm is pivoted and can move back and forth to engage the wheel. The shape of the teeth is such that rotation can occur in only one direction. Used in winch to wind up a cable on drum. CAM. A cam is a body which rotates or oscillates, and in doing so, imparts a reciprocating or oscillatory motion to a second body called the follower, with which it is in contact. Cams as the cam rotates, so the follower is made to rise, dwell and fall. The length of time spent at each of these positions depends on the shape of the cam. The rise section is the one that drives the follower upwards, the fall section is the one that lowers the follower. The dwell section is the one that allows the follower to remain at the same level for a significant period of time. It is circular with a radius that does not change. 10. Explain the principle of process control valves. ANS. A control valve is a valve used to control fluid flow by varying the size of the flow passage as directed by a signal from a controller. This enables the direct control of flow rate and the consequential control of process quantities such as pressure, temperature, and liquid level. The opening or closing of automatic control valves is usually done by electrical, hydraulic, or pneumatic actuators. Normally with a modulating valve, which can be set to any position between fully open and fully closed. Valve positioners are used to ensure the valve attains the desired degree of opening. Air-actuated valves are commonly used because of their simplicity, as they only require a compressed air supply, whereas electrically operated valves require additional cabling and switchgear, and hydraulically actuated valves required high-pressure supply and return lines for the hydraulic fluid. 11. Describe with sketch, basic details of 1. Poppet valve. 2. Shuttle valve. ANS. A poppet valve, also called mushroom valve, is a valve typically used to control the timing and quantity of gas or vapors flow into an engine. It consists of a hole, usually round or oval, and a tapered plug, usually a disc shape on the end of a shaft, also called a valve stem. The portion of the hole where the plug meets with it is referred to as the seat or valve seat. The shaft guides the plug portion by sliding through a valve guide. In exhaust applications, a pressure differential helps to seal the valve, and in intake valves a pressure differential helps open it. Poppet valves date from at least the 1770s, when James Watt used them on his steam engines. Poppet valves are used in many industrial processes, from controlling the flow of milk to isolating sterile air in the semiconductor industry. However, they are most well known for their use in internal combustion and steam engines, as described below. A shuttle valve is a type of valve which allows fluid to flow through it from one of two sources. Generally, a shuttle valve is used in pneumatic systems, although sometimes it will be found in hydraulic systems. Structure and function. The basic structure of a shuttle valve is like a tube with 3 openings, one on each end, and one in the middle. A ball or other blocking valve element moves freely within the tube. When pressure from a fluid is exerted through an opening on one end, it pushes the ball towards the opposite end. This prevents the fluid from traveling through that opening, but allows it to flow through the middle opening. In this way, 2 different sources can provide pressure, without the threat of backflow from one source to the other. In pneumatic logic, a shuttle valve works as an OR gate. Symbol of shuttle valve. 12. Describe the principle of operation of 1. Linear actuators. 2. DC motors. ANS. Principle of linear actuator. A linear actuator is an actuator that creates motion in a straight line, in contrast to the circular motion of a conventional electric motor. Linear actuators are used in machine tools and industrial machinery, in computer peripherals such as disk drives and printers, in valves and dampers, and in many other places where linear motion is required. Hydraulic or pneumatic cylinders inherently produce linear motion. Many other mechanisms are used to generate linear motion from a rotating motor. There are 2 types of linear actuators: I. Single acting cylinder. 2. Double acting cylinder. Following shows construction of double acting cylinder. DC motor. It is based on the principle that when a current-carrying conductor is placed in a magnetic field, it experiences a mechanical force, whose direction is given by Fleming's left-hand rule, and whose magnitude is given by force, F equals BIL Newton, where B is the magnetic field in Weber/m2. I is the current in amperes and L is the length of the coil in meter. The force, current and the magnetic field are all in different directions. If an electric current flows through 2 copper wires that are between the poles of a magnet, an upward force will move one wire up, and a downward force will move the other wire down. The loop can be made to spin by fixing a half circle of copper, which is known as commutator, to each end of the loop. Current is passed into and out of the loop by brushes that press onto the strips. The brushes do not go round, so the wire does not get twisted. This arrangement also makes sure that the current always passes down on the right, and back on the left, so that the rotation continues. This is how a simple DC electric motor works. 13. Draw and explain rack and pinion assembly. ANS, rack and pinion. A rack and pinion is a type of linear actuator that comprises a pair of gears which convert rotational motion into linear motion. A circular gear called the pinion engages teeth on a linear gear bar called the rack. Rotational motion applied to the pinion causes the rack to move relative to the pinion, thereby translating the rotational motion of the pinion into linear motion. Example: in a rack railway, the rotation of a pinion mounted on a locomotive or a rail car engages a rack between the rails and forces a train up a steep slope. For every pair of conjugate involute profile, there is a basic rack. This basic rack is the profile of the conjugate gear of infinite pitch radius, i.e. a toothed straight edge. A generating rack is a rack outline used to indicate tooth details and dimensions for the design of a generating tool, such as a hob or a gear shaper cutter. 14. Classify bearing and explain any one in brief. ANS, bearing. Hydrodynamic bearings, hydrostatic bearings, rolling element bearings. Types of bearings: radial bearing, thrust bearing, sliding contact bearings, rolling contact bearings. Hydrodynamic and hydrostatic bearing. Hydrodynamic and hydrostatic bearings are those which we design and manufacture all by ourselves for the majority cases. These are more specific to the application, costlier in budget, but work really effectively. Rolling element bearing. Rolling element bearings are those which are readily available cataloged products in the market. They are surely cost-effective, just select them from the catalog based on the requirement. Very rarely are rolling element bearings designed and manufactured. Although the bearings are classified into these three types, the varieties each type of bearing holds is enormous. The forthcoming articles will deal more with these details. 15. State the types of actuators. Draw and explain single acting cylinder. ANS 1. Electromechanical actuators. 2. Fluid power actuators. A. Hydraulic. B. Pneumatic. 3. Electrical actuators. 4. Mechanical actuators. 5. Active material-based actuators. Single-acting cylinder. These cylinders produce work in one direction of motion, hence, they are named as single-acting cylinders. The compressed fluid pushes the piston located in the cylindrical barrel, causing the desired motion. The return stroke takes place by the action of a spring. Generally, the spring is provided on the rod side of the cylinder. 16. Compare pneumatic and hydraulic system. Any 4 points, ANS.